Hi, this is Scott Wilkinson, host of Home Theater Geeks. In episode 135, I chat with Paul Darbee about his new video enhancement processor. So stay tuned.
Netcasts you love.
From people you trust.
This is TWiT.
Bandwidth for Home Theater Geeks is provided by Cachefly at CACHEFLY.com.
This is Home Theater Geeks with Scott Wilkinson, recorded November 5th, 2012. Episode 135, Darbee's Vision. This episode of Home Theater Geeks is brought to you by Netflix. Watch thousands of TV episodes and movies on your PC, Mac, iPad, iPhone, or TV instantly. All streamed directly to you, saving you time, money, and hassle. For your free 30-day trial, go to netflix.com/twit. Hey there, Scott Wilkinson here, the Home Theater Geek. This week's guest geek is Paul Darbee, the CEO and founder of DarbeeVision, and the inventor of a very interesting video enhancement processor called the Darblet. Hey, Paul, welcome to the show.
Hi, Scott. Thanks a lot. Great to be here.
So great to have you with us. This is a very interesting processor. I look forward to digging into it with you. Before we do, though, I want to make sure that everybody who's watching live at live.twit.tv or logged into the chat room at irc.twit.tv can post questions for Paul, and I'll pass along as many as I can as we go along. So, Paul, before we get to the processor, I did want to just spend a few minutes talking about your other claim to fame, or perhaps one of several, which is that you are the inventor of pre-programmed universal remotes, which are now so common. They're essentially ubiquitous. You can buy them everywhere. How did that come about?
Well, you know, you can tell, I guess, by looking at me that I've been around for a while. And so,
yeah, you and me both, buddy.
Well, you know, I guess there's one advantage of being older, and that is that you can never die young.
Well said. I'll have to remember that. That's very good. Very good.
At any rate, it was actually a plan B back in the mid-'80s. I've been an entrepreneur my whole life. I mean, even back as a kid in Washington, D.C., I organized the neighborhood kids into putting on a shadow puppet theater. And just right from the beginning, I don't know why that was. But I've tried one thing after another. And to tell you the truth, most of what I tried didn't work out. But every now and then you hit one. And boy, that sure does get into your bloodstream. The universal remote was a 2-year overnight success.
All right.
We were licking our wounds after the failure of another venture after we had been promoting it for about a year. And we discovered that we were way too early with it and could never get funding. And so I remember just sitting around in my partner's condo, and he had a coffee table that had several remotes on it. And so it was one of those things, ideas don't usually strike, you know, just right between your eyes, but this one did. And it was that I knew that the remote worked by sending out some kind of Morse code using infrared. And so it occurred to me that if you could do that using a low-cost microcontroller, if the pulses were slow enough, that you might be able to build a universal remote that could send all kinds of different codes. And so took it into the lab, a bunch of remotes from myself and some friends, and put it on the logic analyzer and found out that, yes, indeed, the pulse train was slow enough that it would work. And so my first remote was a Sony TV. And so I had to give it some kind of number, and the Sony, the first number was 0. So to this day, when you look up in code books, what you're going to see is that the Sony code is typically 0000.
Huh. Wow, because that was the first one you did.
That's right. It was just one of those things that got locked in.
That's incredible. And were you the one that came up with the idea of basically storing the codes from a bunch of different manufacturers into memory, into a database, essentially inside the remote?
Well, that's what it ended up being. The killer app was that it was pre-programmed. The first thing that we developed, because to have a pre-programmed device, you have to have a library. And, of course, libraries didn't exist, the IR libraries of all the codes. And so what I really built in the lab was a learner that was just a system on the bench top that used a PC, and you could shine other remotes into it, and then using some code that we wrote, it would analyze the codes and be able to play them back.
Right.
But to put them all in a memory, you had to compress the codes. And so what we started doing was cracking the codes using HI instead of AI, human intelligence. We actually went into the codes and we figured out, okay, they can't be sending that much information. It turns out it's about 1 byte per function. And so we usually got it down to that theoretical information minimum. And that was really what set us apart. And to this day is very important, was that we were very parsimonious with the memory. And that way, using even small chips, we could put a lot of different devices in there. And the way the market sorted itself out was how many devices could you control with a remote? And so the price point was, if you could control 3 devices, it was a lower cost device than if you could control, say, 12. Mm-hmm. And that made a little bit of sense because it did take more memory. But we did it in just a dab of memory, and that to this day has been very useful. In today's world where you can have as much memory as you want, it still has value to be at the minimum.
Well, sure, because you got other things you could put in there. Also, the pre-programmed capabilities of universal remotes is also good in that instead of having to teach the remote your particular codes, you just have to enter in one code or another to tell it whether you've got a Sony TV or a Panasonic TV or whatever. It makes it a little easier for the end user, I would think.
Well, that's true. It is easier, even though we had a helpline that was fielding, 1 million calls a year to help with that very thing, because you did have to set up. But
yeah.
That was the killer app, and the reason was why people bought these remotes was because their dog ate their original remote. It was lost. What are you going to do back in the 80s if you lose your remote? You'd have to go back to the store where you bought it. It was a special order. It might cost you $100, and you have to wait 2 months before it came in. So this actually solved, that was the pain, lost or broken. The learner won't help you. You don't have the original.
Right, exactly. I always thought the universal remote, the killer app, was to get rid of all those remotes on your table, but on your coffee table. But you're saying no, it was because those original remotes got lost or stolen or eaten.
Well, that's what put us on the map. Until, of course, we started putting bone meal in the plastic, and that really boosted itself. I'm joking.
Yeah. Now you start in this process. You started Universal Electronics, right?
That's right. Started a company right away after it was pretty clear that it was going to be possible to do. And so we built 10,000 remotes right away thinking, oh, boy, these are going to really sell like hotcakes, And, boy, the first 10,000 came back and there was a bug in there. And we had to go through manually and do the cuts and adds to try to fix the bug. And even then, we couldn't sell them right away. We managed to get a few of them into mom and pop video rental stores. Is about the only place we could put them. It took a while before we finally got them into the back room of Montgomery Ward's. Was the first reasonable sale that we got, and that was to solve the lost or broken problem. But after that, the buyers in the store proper said, well, why in the world isn't this on the shelves out front? And he's, well, I'm glad it's your idea. I mean, we've been talking to you for 2 years about it. When it is their idea, then you know that that you're good to go.
Right. Lawn Dog in the chat room is saying, how do you feel about the Harmony remotes taking your idea to the extreme? It was a question I was going to ask, too, actually. Lawn Dog beat me to it.
Well, I love the remotes and where they've gone. I mean, the original motivation really was consolidation. You know, take that coffee table full of remotes and put them all into one. But that turns out actually to be a very hard problem. You can only have so many keys, and so it's a depth versus breadth menu user interface problem. When you finally put displays on the remotes, which Harmony has done, then you can have a richer user interface, but then it's still quite complex, and you really do have to fiddle around with it. Simple is hard.
That's a good phrase. You should use that on some marketing campaign. Simple is hard, and here we've done it.
Yeah. You know, as far as consolidation goes, I have a lot of remotes still on my own coffee table, and the only difference is I've still got a lot of them, but they're all universals.
Well, one of the problems. Certainly, one of the problems with universal remotes, as you just said, is that they can't replace the original remote completely. In fact, Web4483 in the chat room is saying, I don't get the ability to navigate the menu system on my TV properly. Why not? Very few universal remotes allow you to do this. And I haven't had too much trouble with universal remotes navigating a menu system. But when you have to go in and do something strange that might use one or another button or function of the original remote that isn't easily mapped, as I think you mentioned, onto the universal, it makes it difficult, which is why I always recommend to people, if they have a universal remote, even something as sophisticated as a Harmony, to keep your original remote around, because there may come a time when you'll need to use it.
Amen to that. You know, I wish I could say that we've done a better job of consolidating. I mean, universal electronics.
It may not be possible.
Well, it would require some kind of artificial intelligence, you know, with an RUM, read user's mind instruction, it seems like. UEI does have the best code library in the world. I think they're pushing 500,000 codes. And that's the problem. Even though they have all of the codes and you can get them from the website, it's still, for a pre-programmed universal remote, you have to do something that we called the pick, where you choose which functions are going to get mapped to whatever keys the remote model has. And so you're constrained, and that's why certain things get left out. And the best you could do if you do have a screen is to put them deeper in a menu. And you're never going to make an optimal choice because you're not going to map to the original remote.
Right, exactly. What do you think about physical button remotes as opposed to touchscreen remotes?
Well, I think Steve Jobs showed us that touch screens can work actually quite well. I mean, I was very dubious that you would be able to do a QWERTY keyboard, say, on a touch screen, because there's no real tactile feedback. Mm-hmm. Although that's been improved a bit now, because the HTC phone that I've got, for instance, buzzes the little motor when you hit the key, and so you do get some AC coupled tactile feedback, if you will, and that helps. But you can't really feel around with your fingers where the physical keys are. So for that reason, you know, we resisted doing it for a long time. Also, I was always worried about goobering up the screen, which you do when you touch it, but that turns out not to be a very bad problem.
Now, there's a verb I hadn't heard before, goobering up the screen. I'll have to remember that one, too. I always preferred physical buttons for a home theater application, particularly for two reasons. One, you mentioned, which is being able to find the buttons by feel, not having to look at them. But two, if you do have to look at the screen, it's usually pretty bright, and it may affect your the dark adaptation of your eyes in a dark room watching a TV that may not be as bright, may not be putting out as much light as this remote screen, which is closer to you, smaller, really putting out a lot of light. It may affect your vision for a little while. So for those two reasons, I generally don't prefer touchscreen remotes.
Well, I'll agree with you on those two issues. I guess the dark adaptation thing can be helped to some extent by making the backlight red,
True.
which doesn't ruin the cone vision that well. I guess the rod vision is what I mean. That badly. But yeah, being able to work a remote just by feel is has high value, I think. So really, I guess the best you can do is a trade-off where you have some buttons, and then you have a screen that can label them. Wouldn't it be nice if you had morphing material which could have buttons that would just sort of pop up with displays right on them whenever you needed them, and then go away when you didn't, so that you could just have an uninterrupted screen. So maybe we'll have to wait for nanotech or something for that. But it has
next
a long
big
ways
invention.
to go, doesn't it?
Yeah. Your next big invention, I would say.
Oh, I don't think so. I'll wait for someone else to do that.
Beatmaster is asking about how much does the iPhone and Android control apps, which we're starting to see a lot more of these days. How does that affect the universal remote business?
Well, I hope that in the long run it affects it a lot, because in truth, remote control never should have been IR. It should have been radio to start with. But
good point.
There were problems back in the day in making a radio that small. And so the IR LEDs did come out, and they replaced the sonic remotes. And
I remember.
Yeah, I even had a remote that was a squeeze ball connected to some aquarium tubing that would make the channel dial go around.
Boy, I remember, I think it was Zenith that made the magic remote. It's where we get the term clicker, because it actually made a clicking sound, which was actually what you could hear, the audible component of an ultrasonic signal that the TV responded to change the channel up, down, or change the volume, I guess, as well. And that was all you had. Channel up, down, and volume up, down, I think, was all you had.
Pretty much, yeah, 4 functions. You might have power on there, 5 functions. And though some of them were actually little tubes, like the kind you see underneath a vibraphone, much smaller, of course. So
right. Resonators.
Sonic. That's right. I guess they are resonators that would actually get hit by a mechanical mallet. And the problem was that when your dog came through with their collar jingling, sometimes the channel and volume go out.
That's right. Yeah, that's right. Okay, well, great. I've got a couple other questions in here, but I would like to start. Just checking out the. Oh, that's a good question. Fred Flintstone is asking, how big is the universal?
Hi, Fred.
The universal. Hey, Fred. How big is the universal remote code database now? Do you have any sense of how many kilobytes? Certainly not in the megabytes, I would think.
Well, it like I say, it's about a byte per function, and the way it works is that you have a database of a byte per function for every function that you store in the remote, and then for every type of device you have a formatter, or we called it an executor, that was a snippet of code that would take that byte and then decode it and unravel it into a bit stream.
Gotcha.
And so it's some number of executors, which can, of course, be in the thousands, and then tens of thousands of codes would go in a typical remote. And memory being so cheap, you can, put pretty big memories in there now compared to what we used to do, which we'd cram whatever we could into, say, 8K or so. Now, the handcuffs are off.
Off, totally. This reminds me of one question I wanted to ask you before we move on. You said that Universal has a library of something like 500,000 codes at this point.
I believe so.
Yeah. I really like the Harmony approach to this, which is to maintain the database outside of the remote, that is on a central server. And whenever a user, encounters a device that's not in the database, they teach the Harmony remote the codes from the source remote that's not in the database. That information then gets uploaded into the offsite database and gets added to it, and it's essentially infinitely expandable. And then when you program your remote, you say, I've got this TV and that AVR and this Blu-ray player and so on. It just downloads the codes that you need for those devices back into your Harmony remote. So it's got some flash RAM. It doesn't have to have ROM with everything in it, only enough to store the codes that you actually need while the total big giant database is in the cloud, so to speak.
Well, isn't it great to have a cloud? I mean, we certainly dreamed of that in the early days. We sort of were the cloud, but you had to use snail mail or something in order to get your remote back to us. And really, to build the database, I mean, because the library really wasn't all that good to start with. What we did was we offered a double your money back guarantee if we didn't control your TV. But the way that actually worked in the fine print was, you had to send in your TV remote along with the one you bought from us. So when people did that, and so we would capture the codes, similar to what Live Tech can do right now in real time.
So that was worth double your money back to get that code. They'll get those codes, huh?
Well, we didn't have to pay it because we did end up controlling their TV.
I got you. Okay. Yeah. Gotcha. Okay. Well, listen. Let's get on to your current work, which is with DarbeeVision, a company that has made some very interesting video enhancement algorithms, which are now implemented in your one and only product so far, the DVP5000, also known as the Darblet. Give us an overview of what you're trying to do with this product and with these algorithms.
Well, another advantage of having been around a while, you can circle back around on some things that you might have done earlier in your life. And this is one of them. As a pretty young man in my early 20s, I was interested in all things video, and so designed and built an analog video synthesizer. And we kind of laugh at analog stuff these days, but one property that analog has is that it's all in real time. It's what you see is what you get. And the synthesizer worked like most synthesizers do. It was essentially a patch panel that you could connect a lot of gizmology to. And so it let us do things with multiple cameras and processing units, multipliers, adders, things in the frequency domain, and so on. So it was possible in a very short time, using the real-time properties of the device, to do a lot of experiments with video that would have been difficult, I think, for other people to do. And, being young and stupid, we tried things that you probably shouldn't have done. And so
you mean like aiming a camera at a video display and getting feedback?
Absolutely, we nailed that one real good, and we found out how to in fact stabilize that. And in fact, that whole thing is of great importance these days because it's a primary example of an iterated system. And yes, so that's part of.
Looks like we froze. That Paul froze his Skype. I'm so sorry about that. John will get him back momentarily. And meanwhile, thanks so much to everybody in the chat room for chiming in on all sorts of stuff about universals. Most cable company remotes have universal built into them. That's true, Swami. You're able to turn your devices on and off, adjust the volume, and so on, which is 99% of what people need anyway. True enough. I'm not sure if the universal remotes that you get with your cable box are able to do things like go into the menu of the TV or the AVR and do some of the more sophisticated things, which, as you say, may only be 1% of the time that you need to do it. SoCal Ray Jr. and several others are talking about Universal Remote Control, another company that, aside from Universal Electronics, which is what Paul started, that they make very nice remotes, and it's true they do, but they're much harder to program than the Harmonies. So if you're going to have a technician program your remote, or if you're a super geek, which many watchers to this show are, then in fact Universal Remote Control would be very good. But if you're not and you want to get into it sooner than later and not have to really worry so much about it, the Harmony remotes for me are the way to go.
Yes.
So we were talking about iterative functions and aiming your TV camera at your TV screen and getting that feedback loop, which you don't want to do with microphones. I was going to ask you this question. You mentioned that you had started this whole process in your 20s working on a video synthesizer, and I was going to ask what was similar about that compared to the audio or music synthesizers for which Robert Moog became famous, for example.
Well, yes. Actually, they conceptually work pretty much the same way. The audio synthesizers are essentially a patch panel or a matrix switch with various oscillators and filters and other processing devices that can be connected to one another through a patch. And so that's the basic idea behind pretty much any synthesizer. And the video synthesizer is no different, except it's running video signals, and they're all synchronized to a master sync generator. And so everything is gen-locked, as we say, and so that you can use the patch panel to multiply and add in other signals, for instance, or you can do things in the frequency domain, and you can do colorization and other kinds of things that, of course, are not possible with a one-dimensional audio signal.
Right, but you don't get the the damage, I don't think, when you're doing video feedback as opposed to when you're doing audio feedback, right?
Well, you run to saturation. What happens in a iterated system, if you don't high pass it, is that it will run to the rail. And in the case of audio, of course, it'll just go into that squeal, which is saturating at whatever the resonant frequency of the sound system is. And in the case of video feedback, what you'll either do is you'll run to a black screen or you'll run to a white screen. And so what we discovered was the importance of high passing the video in order to break it up into what is now called the edge of chaos in complex systems. In chaos theory, you want to get to that sweet spot, which isn't at either end of the spectrum, the complexity spectrum, but right in the middle. And so if you high pass the video signal, then it creates local competition amongst pixels and breaks up the image into very interesting patterns that then you can get some control over and have a lot of fun with.
By high pass, I just want to make sure everybody understands, you're applying a high pass filter which lets higher frequencies through but blocks lower frequencies from getting through, right?
Yeah, that's in general, that's what it is. There are many ways to implement it, but yeah, that's exactly the idea.
Okay, just wanted to make sure. Okay, so how did the current product that we're going to be talking about arise out of these early experimentations with analog video synthesizers?
Well, one set of experiments that I was able to do was with two cameras, left and right, like your left and right eyes. Well, the cameras were kind of large, so you couldn't get them as close together as our eyes were. So you had sort of a hyper 3D effect. But one of the first things we did was color one of the images red and the other blue and look at them with red-blue glasses, the so-called anaglyph stereo. Yep. So back in the early 70s, we were actually watching stereo TV on a Sony monitor. So we knew what it looked like to have the picture in real 3D. But what I was really trying to find was some way of embedding the depth cues that I knew were somehow encoded in the difference between the two signals and seeing if it was possible to get that information into a single two-dimensional image that you could look at without glasses. So that, naively, if you just add the two images together, all you get is a double image. That clearly doesn't work. Right. And so we just pretty much fooling around, we discovered that if you defocus one of the images and then use your handy-dandy synthesizer to subtract the blurred signal from the sharp one, then a very strange thing happens. Where the images are different, you've put in some luminance modulation that challenges your visual system to make sense of what it is that you did. And it's an illusion, but it looks very, very depthy. And that was something that was totally unexpected. And certainly remembered about it. And I knew at the time there wasn't anything you really could do with it. But boy, was it a strong effect, depending on what it was that you were aiming the cameras at.
Right. Now, SoCal Ray Jr. in the chat room is likening what you're talking about to edge enhancement.
Well, as a matter of fact, that's very perceptive. It has been well known for, since the photographers discovered it in the 1800s, that if you defocus an image and subtract it from itself, that is a sharpener. And its name is Unsharp Mask. You can find it in Photoshop and all over the place. It is I think the classic sharpener. That is a form of image high passing. And it also has all of the well-known artifact problems that that kind of naive sharpener produces. You're going to pop the noise as well as the picture, and you're also going to ring the edges. And so it is true that if you start with a stereo pair, that in that subset of the image where the cameras are converged, where the images are the same, that you do get a sharpening effect with all of the artifacts that you would get there.
Now, Moon in the chat room is asking, is this also known as the Pulfrich effect?
No, Pulfrich effect is, that was actually used on a Rose Bowl parade back in the 90s. And you could go down to 7-Eleven and buy some glasses where one eye was clear and the other eye had a neutral density darkening filter in it. And so it turns out that you I guess, are really swapping motion differences in time. You end up seeing as differences between your two eyes. I'm not sure the neurophysiological source for that phenomenon, but it's a pretty good phenomenon. And for the Rose Parade, where everything moved horizontally, it worked pretty well.
Eric Duckman in the chat room remembers those glasses. I'm afraid I don't. Although I've been a big Rose Parade fan for a long time, ever since I marched in it in high school, but that was a long time ago.
Well, just like you probably never marched in it again, they never used the Pulfrich effect again either. So
only the one time. Okay, all right, I got you. So we've been talking about those stereo images, and I think, if I'm not mistaken, and I think I'm not because I have a Darblet here that I've been playing with for the last week or so, it's the product that you now have is not being applied to 3D imagery.
That's correct.
Actual stereo imagery, I should say.
No, in fact, just to finish the story, I went on to other stuff, and of course in the mid-'80s did the remote control for about 15 years and so on. And it wasn't until 2000 that after I left Universal Electronics that I decided to resurrect this and get another really good look at it, this time in digital space. And so I wrote some code that recapitulated the entire synthesizer, but this time digitally. And it was on a PC written in Windows, so it was pretty darn slow. I gave up real time, big time. It was about 500 times out of real time. But because it was digital, well, we had a chance to really get a good look at some high quality imagery, and boy, the effect was absolutely still there. And so that's what motivated me to decide to try to develop it further to the point where it could be commercialized, because it was so beautiful that I figured, well, if images could look better, probably they should. And Moore's Law was alive and well, so I realized that there were numerous steps that would have to be taken in order to make this thing practical. And the first thing was that you couldn't start with stereo pairs, because where were you going to get them? Even with the hysteria over today's 3D, it's still content is the problem. There isn't a lot of 3D content.
That's right.
There was pretty much none in the early 2000s. So I realized that it's a 2D world out there, and you're going to have to start with a monoscopic two-dimensional image. And so the first challenge was to somehow make the other image that you needed. And so there's quite a lot of 2D to 3D software out there, but there wasn't any that I knew of in the day. So I couldn't copy anything. I just had to cook something up. But because I knew that all we were going to do with the image was to defocus it in order to subtract it from the incoming sharp image, that you could take some shortcuts. And it turns out that I did find something mathematically tractable that allowed me to create the missing image. And in fact, it was cheap enough, mathematically speaking, that I was able to create from the incoming center image both a left and a right view estimate of what the scene would look like. So I created two new phases from the incoming single phase.
So you essentially derived a stereoscopic image from the single image. As you say, a lot of people are doing that, including Gene Dolgoff, the fellow I've had on the show a number of times, who has a 2D to 3D converter. So your system does that, but then only in order to apply this sharpening algorithm and recombine it and make it into a 2D image finally?
Well, yes, I don't like calling it a sharpening algorithm for a reason that I'll get to.
Okay.
What we do is we create a left and a right image, defocus both of those, and subtract them from the middle image. So it's a left, middle, right system. And so in the places where the image would be converged and you did the defocus and subtract, then you have that problem that you get with a naive unsharp mask, namely that you would sharpen noise and also create ringing on edges. So we absolutely do not do that because we don't want to start off creating problems that would be difficult to get rid of later on. So that's why we don't claim that it's a sharpener. It is true that it does have side effects of seeming to sharpen the image, and in fact sharpening the image in various parts of it. But the reason for that is that the creating the left and the right images and defocusing and subtracting is really only about 15% of the algorithm. The remaining 85% is a bag of tricks that we call the perceptor. That's a name I sort of made up because in some sense it's based on the neurophysiological ideas of how you pay conditional attention within an image to just parts of it. And so we run a type of saliency map, as it's called in the trade, which does an estimate of what is it that's of visual interest within the frame. And then we conditionally apply the underlying defocus and subtract algorithm according to what we think is what the perceptor thinks is interesting within the image.
So you don't apply it equally over the entire image.
No, I think maybe there's sort of a Hippocratic oath of image processing, and it is above all do no harm.
Right.
You know, don't make the picture any worse. And so that's what you would do if all you tried to do was sharpen. But in fact, that's not what we're trying to do. We're grateful when that happens, but what we're really trying to do is put in a form of what is really drop shadow. And as a matter of fact, let me just show you an example of that. I think this should show up. Here's something I picked up off of the airplane going to New Zealand. Can you see how that lettering that says shopping has a drop shadow effect to it?
Yep.
It does. Even on the webcam, it seems like it's popping off the surface. like it's in front of the background. Well, that's not true. It's an illusion, but it's a very powerful illusion. And again, you've made a modification to the picture. In this case, with text, it's quite simple. It's just to put a little blurry replica of the text itself down and to the right of the text. And when you do that, again, you've challenged the brain to make sense of what you've done. And the easiest thing for it to come to the conclusion of is that it's what you normally see, 3D. 2D is the outlier. 2D is actually a technology. I guess we've all seen those charming little pre-Renaissance drawings where people had not invented perspective, and they drew the background objects all the wrong size and stuff. And so
exactly.
It didn't work until it got invented. But now that it is, and it's so ubiquitous, we take it for granted. But in reality, cradle to grave, what we mostly see is real stereoscopic 3D. And so it turns out, given half a chance, you're going to go along with the illusion. And so I think what we've ended up doing is we've found a way to use silicon to put a form of drop shadow into images in general.
Wow. Well, we're going to take a look. We're going to take a look at a few examples of this process here in just a minute, but I hope you'll stay with me while I take a few moments to thank our sponsor for this episode, which is Netflix. Now, of course, Netflix, as most of you already know, lets you stream thousands of TV episodes and movies directly to your TV or your PC, your smartphone, your tablet, your gaming console, standalone boxes, just about Blu-ray players, any consumer device you can think of, consumer electronics device, will have a Netflix app on it, which will let you stream those thousands of TV episodes and movies directly to just about any display device you happen to have in the room, your TV or your computer or your smartphone or tablet or whatever. You can even start on one device and finish on another, providing you the ultimate inconvenience. And for one low monthly subscription fee, you can watch absolutely as much of that content as you can take. For our listeners, Netflix is offering a 30-day free trial at netflix.com/twit. And we want you to please be sure to use that URL, netflix.com/twit. And we thank Netflix very much for their support of Home Theater Geeks and the entire TWiT network. So, Caffeine-Free Dave says in the chat room, there you go, no 3D glasses. And you're going to get something of a 3D effect. It's not going to be true 3D or true stereoscopy, but you are going to get a sense of depth. And we're going to take a look at a couple of examples that you sent me before the show, and I put together as a sort of a before and after. So, John, if you can pull up any one of the examples that I sent you to take a look at here. Here is a photograph of, I guess they're cannonballs. They look like metal spheres stacked up in a kind of a pyramid. And tell us a little bit about what we're seeing here, Paul.
Well, that's a classic example. I see that, at least on my screen, I don't get the entire picture, but you can probably see the difference. On the right is the processed image, and what you can see is a much more profound sense of depth and clarity, I would say. It just
on the left is
natural.
on the left is the source image, and on the right is the processed image.
That's correct, and we often get blamed for just not really doing anything other than soften the original. So it's kind of a joke. In fact, you asked that question: what happens if you pass the signal through the Darbee? Do we somehow degrade it? And the answer is no, we don't touch it at all. So what you're seeing is what the image could have been if this process were applied to it.
Right. And I want to point out that what you're talking about is the Darbee processor, which is just this little tiny box. I guess
right here.
Oh, you got one right there. There it is.
Yeah, there it is.
The Darbee. It's got a power connector so that you plug it into the wall, and it's got an HDMI in and an HDMI out, and a number of indicators and buttons. And I'm not sure if are there buttons on the unit itself or only on the remote?
There's both. We wanted it to be possible to control the unit without the remote. So we put enough buttons on the unit itself so that you could control it locally.
And interestingly, there's the innards. Okay, good.
There's the guts. Yep.
Very good.
Four chips, basically.
Mm-hmm. And the controls have an on-off switch, basically, that let you bypass the process. So you sending the HDMI signal through it, you can establish how much of the effect, how pronounced the effect is. So from 0 to, I think, 120%. I'm not sure why you went beyond 100%. I'm not quite sure what that means. I'll ask you that in a minute. But whatever you set it to, you can then say effect on or effect off and compare them. When you turn it off, it actually, even high def images tend to look a little soft. And I was thinking maybe there's some degradation going on through the processor, even though you're not doing ostensibly anything to the signal. But you're saying no, that you're not that the signal's passing through unaltered in any way.
Well, yeah, Scott, that's true. You're not the first person to say that, because some images, especially off of Blu-ray players, can really be beautiful, and you think, well, this is the best that can be done. And as far as fidelity goes, it's very close to what the environment gave us, but it isn't. The end point is what we've discovered. Fidelity, if you did have a perfect match to the environment, that's not, you can still go beyond. And in fact, the artists in the Renaissance, some of them discovered that with the so-called trompe l'oeil, the trick the eye effect. And so some bowls of fruit or maybe a portrait of a head or something have this remarkable dimensionality to them. And in fact, if you go and look closely at them, it turns out that it really is the same thing that we do. So no camera, no matter how perfect, could ever do it. And artists, of course, are not cameras. They could paint, if they had the talent, to please themselves. And so in a way, I think we've, 400 years later, we've found a way to do that with silicon.
How interesting. Let's take a look at another couple of examples. There were a couple of examples that you sent me from animated movies. Like here's
Finding Nemo.
Finding Nemo. Right, exactly.
Right.
And you can see on the right, the processed image is quite a bit sharper. Unfortunately, we can't see it that well on this web video. You can go to your website, right, and see these examples as well.
Yes, you can download them in high resolution if you want and have a look at them any way you like. But it is remarkable that even through this compressed channel that you can see the effect. And, you'll notice that the shark's teeth and the nose and so on seem to have more roundness and naturalism to them, to the extent where the original image on the left does have that property where you think, well, why in the world would anybody do that? Well, I'm here to say that's a pretty darn good source image. And, if that's all you saw, you wouldn't think there was anything more that you could do. But it turns out that's not the case. There is. We've adapted the image in a way that is similar to some of the processing that the brain is doing. And so the image is actually helping you to see it.
Now, Tinker Toy Tech in the chat room is asking, are you using field programmable gate arrays?
We are indeed. In fact, the main chip in the unit itself, this central chip right here, is an Altera C4 family chip, and it's the C40 size. And all we use in there is 700K bits of RAM, not bytes, less than 100K bytes of RAM, and 17,000 logic elements in FPGA speak, which would translate to about 80,000 gates in a regular integrated circuit.
Which really isn't that many these days.
It's about 6 cents worth of silicon in a big chip that already has 1 billion transistors in it.
So Swami in the chat room and a couple other people as well, Eric Duckman, are asking, they've gone to the website, DarbeeVision.com, and found that this unit, the Darblet, also known as the DVP 5000, retails for $320. And are wondering, that seems relatively expensive. So how did you come up with that sales price? I assume FPGAs, for example, are more expensive than what are called ASICs, application-specific ICs, in which the algorithms are burned into the silicon permanently, and you can stamp out 1 million of them. FPGAs, I know, are more expensive. Is that part of the reason why this processor is on the expensive side of things?
Well, yes, we don't deny that it is, unfortunately, a rather expensive unit for us to build. And the real reason for that is that the bill of materials is not cheap, but even more importantly, we're not in very high volume on it. We're in the thousands. We build them 4,000 at a time right now, which is helping. But we have a ways to go before we can do the type of cost reduction that will enable us to get it into the mainstream. And so the most important milestone there is to get it out of 4 chips and into a single chip. And that project is underway. I'm happy to say, and thanks everybody for buying Darblets to help us to afford to do that. But it's going to take us about another year before that piece of silicon is available. And when it is, we can do a dramatic cost reduction on it. I hope you don't wait a year to sample it. We are planning some cost-reduced versions of the 4-chip unit where we can achieve some savings by giving up some features. For instance, instead of processing deep color, we could go, say, to 8-bit color, which should be satisfactory for video games and that kind of thing, and we should be able to charge somewhat less for that kind of product. So we've got that in the works right now, but we don't have a release date for that yet.
Now, Beatmaster chat room asks, does it pass other parts of the HDMI signal, for example, 3D? And I was going to ask what it does to a 3D image, but let's put that aside for a moment. Or audio return channel, ARC, or Ethernet over HDMI. Will this system be able to let those things pass through without trouble?
Well, it is HDMI 1.4 compatible, which does include the ARC and the HEC for the audio return channel and the Ethernet channel. But unfortunately, due to some glitches in our software, the audio return channel is buggy. And so we're working to fix that. But right now, if you buy a unit from us, it's going to have that problem. These units, as they currently stand, can have new software zapped into them, but not in the field. So the only way you can get them upgraded would be to send them back to us. And so we don't charge for that, but it is, and I have to apologize, a bit of a hassle. But there is an insurance policy that if you absolutely must have ARC and you are willing to wait until we put the fix in, then we can upgrade your unit.
There's another example of, and there it is in full 16 by 9. Thank you very much, John. And you can see, it's hard to see in such a small image, but you can see on the right that the hair has more detail. It really is kind of a drop shadow effect. You do see some more delineation between parts of the image, and I would imagine that the hair is one of the things in this image that is getting processed more than other stuff. You also see more clear definition in her skin, again, when you look at the high definition image, it's much clearer to see the difference. But I'm just pointing out that this thing does in fact do what he says it does, and some people might object to it. Purists might very well object to it because there is an aspect of edge enhancement to it. It's not as egregious as edge enhancement, straight ahead edge enhancement at all. There, Paul, you're back with us.
Let's give the editors a clean place to
Yes,
start.
I felt a disturbance in the force.
Okay. So, you remember the question that you're going to ask. All right.
3D, yeah.
Here we go.
So, Paul, what does happen when you pass a 3D signal through the Darblet?
Well, that's a good question, and we were curious to find out what would happen too until we ended up. Well, actually, we did know what would happen because we have a software version of this, which let us get an early look at it. But to see what it does live is really the Darblet itself is agnostic as to what it's processing, and to it's just two frames where previously there were one, the left and the right, which it processes independently. The processing that we do does not have a frame buffer. Everything is done intra-frame. So it's really just processing two frames. And so what we end up doing is adding additional depth cues to the left image and also to the right image. And so at first we thought, well, what's that going to do? Is it going to overdo it, or is it going to look strange in some way? It turns out that the answer is no. It does what we call completing the 3D. And it depends on the quality of the 3D image to start with. And you certainly do get wonderful depth separation and disparity that you cannot get with what we do. But sometimes along with that, you also get cardboarding. In other words, it looks as if the objects, while they're very separated, are not all that round. That they're kind of cardboard cutouts, and especially on video games where the 3D is computed quickly, they take some shortcuts that enhance that effect. It especially shows up in the background. And so we put the roundness back in, and so, you might call it 3.5D or something like that. Have
all
a
right.
look for yourself,
Yeah. Now, somebody in the chat room is asking if I like it, and the answer is yes, I do. At a certain setting. Now, as I mentioned earlier, you can set it to 0% up to 120%. And let me ask you that right now. Why, this amp goes to 11? Is that why you went to 120%? What does that mean?
You've pretty much got it. Yeah. It turns out that the scale, like many scales in technology, was in fact arbitrary. And so we chose that numbering system really so the amp could go to 11.
Okay, but when I did that,
people would wonder otherwise, what the heck would happen if you sort of overdid it, and that you can get your own answer.
Well, and I did get my own answer, and I saw some very serious artifacting at 120% on a 65-inch screen. So I backed it off to 50, 60%, and I like it. I like the way it looks, I have to say.
If you go onto the forums, we certainly were biting our nails around here when we first released the product back in May as to what the calibrators and the purists would say, the real golden eyes out there. We have a lot of respect for them being that way ourselves. And so we were aware that at certain settings and with certain image content that there would be artifacts. So we took a couple of different countermeasures to that. One is that there are also 3 viewing modes. Excuse me. One viewing mode is what we call full pop, which in fact is the most aggressive, and that may have been the mode that you were in when you turned it way up, because it is most susceptible to artifacts, especially on text or things that look like text. And so that is not for everybody. The next mode down is, or up, I guess I should say, we call video gaming, and that's for clean video such as computer-generated animation and video games. And there we do more artifact removal. We use more of the perceptor algorithm bag of tricks, and we remove more artifacts. And then for the purists, we have what we call high def mode, which gets rid of pretty much everything unless you have the setting way up high. And so the real sweet spot for the people who already have excellent systems would be what you have discovered. This has been blessed in the forums as a set and forget setting. People have said it's like putting a better lens on your projector, say.
Well, I have to agree. I ended up in the HD mode, which is the least aggressive mode, at about, I think I'm at 60% right now. I'm still playing around a little bit with it, but it really looks great. So I have to congratulate you on a fine product. Certainly the first one out of the gate, and I know you're going to be continuing to develop it. One other quick question here from the chat room. A couple people, F-Loop and Beatmaster, are talking about, well, what we've seen here on the show are examples of still images, and wouldn't it make a noisy effect in moving images? And Beatmaster's asking, aren't there any examples of moving pictures? And I believe you have some on your website, right?
We do indeed, yes. You can go on the website and you can download some stuff there and look at it at your leisure. It's probably better to download it. We have some very lightly compressed material which will give you a good example of some pretty high quality stuff with the algorithm applied to it.
Rusty Bones has asked. Sorry. Oh, sorry. Go ahead. Go ahead, please.
Well, I should also say that they're bringing up the idea of would motion be different from stills? And as I tried to say earlier, we don't use a frame buffer. We don't take any information from the prior or the subsequent frame, and so everything is done as if it were a still image, and then it's just whatever frame rate you're getting, say 60 frames a second, that's what we process, and we do it 60 times every second, in each frame independent from the other, so there cannot be any motion effects. Also, the overall lag is about 2 microseconds, so there's no real problem with we don't even resync the audio, so there's no lip syncing problem or anything like that.
Incredible. Well, listen, we've come to the end of the hour, and I want to thank you so much for being here and explaining to us not only about the Darblet, but also your experiences with universal remotes. Fascinating hour. Thank you so much, Paul Darbee.
Well, thank you very much, Scott, for inviting me. It was a great pleasure.
Good. Thank you so much. As we've mentioned before, you can find out more about the Darblet, the DVP 5000, at DarbeeVision, DARBEE Vision.com, where I'm sure you can order the product as well. Also on Amazon. I see in the chat room there are only a few left on Amazon. Perhaps some folks have been ordering it lately. But in any event, that's where you can find out more about what Paul is doing with this process and any future developments there as well. You can email me, as always, at scott@twit.tv. And you can read some of my stuff online now at hometheaterhifi.com. Next week, my guest geek is scheduled to be Lore Kramer, who used to be at DTS, but he's now at a company called Smith, SMYTH, makers of the Smith Realizer. Now, this is an amazing thing. It creates a 5.1 surround sound field in a pair of standard 2-channel headphones, and it's by far the most convincing 3D sound 5.1 simulator that I've ever heard. So we're going to get the lowdown on exactly how that works next week. And I do hope you will join me for that. Until then, geek out.